So, if you guys remember the practical section of part A, what you are doing is you are taking an amount of acid and you add pheno, which is our indicator. With pheno, it is going to be colorless. And then we are adding mil by mil a base, and that base we add until the solution turns pink. So I have, say for example, my beaker. There's no liquid in here. This is all just kind of miming it. I have my acid in my pipette. I took 1 mil, I put it in there. I put my indicator in there, and then I take my base and I was going mil by mil, counting until how many times it took it for it to turn pink. And then I write down this number here. So that's telling me the ratio. So right now when I'm looking at this, it says for 1 mil of acid, I need 32 milliliters of a base. Now, if we were thinking about this logically and I was doing some titration, we know automatically that this titration would be hell. It would be unpleasant, and I would not suggest you do it. It would be a great way to waste my reagents, and let me kind of show you what I mean by that. I'm just getting some other colors. So just as a reminder, achieved is in red, merit is in blue, and the excellence is in green. And then anything that is just me kind of like breaking apart the question and decoding, I'll put in orange. So that'll just be like processing the question. We good? All right. So right now, hypothetically, if I had 1 mil of acid and I was using the base, I would need 32 mils of it. If we are thinking about scaling this up to titration, we think about our pipettes, and the smallest pipette I can provide for you is 10 mils. So I would have 10 mils of acid as my minimum if I had it undiluted. So we've taken that 1 mil, we've times it by 10. How much would I need base-wise if I did not do any dilution? Times 32 by 10, and I would need 320 milliliters of base if there was no dilution. Do we see that there is a problem here? I cannot use that much base in one titration. It'll burn through reagents. It will also mean that I'm refilling my burette, and my burette can only hold 50 mils. So I'm going to be refilling it a lot of times. And each time I refill it, I'm increasing that chance of mistakes. When I'm looking at these two things, which is more concentrated, the acid or the base? The acid, because I need a very small amount of acid versus the amount of base I'm using. So keep in mind when we're looking at this, the acid is more concentrated. So what am I supposed to do then? Dilute the acid. I don't know if you see this in math sometimes, but that's what they're there for. Now again, I'm just writing this down. This is not part of the assessment for you to do this. It's just to help with the processing of understanding why we're doing it. However, if you do write this up in the final section, with this, which is justifying your method, you can. This information is useful. All right, the next thing I then look at is my planning section and thinking about, okay, what has been provided for me and what can I do? So I have been provided 2 different pipettes. And these pipettes are important because what they tell us is what volumes am I using in order for my dilutions, and also what volumes am I using for my aliquots after I have done those dilutions. So these are the pipettes that I'm working with. The other thing that I've given here is the volumetric flask, and the volumetric flask here are talking about how I'm going to make my dilution stock. So basically we're thinking about the combination of pipette and volumetric flask so we can see how much can be diluted by. So we will give you that information. This information you guys will be able to find on your assessment sheet on the front cover. So on the teaching copy, you should see that there's a set of instructions. I'll just grab that real quick so you guys can see it, what I'm talking about. There's instructions to what you're doing. But the other thing in the instructions is that they tell you what you're being given. So that's where you're gathering that information. In these practice examples, I've just told you it, so that way there's less paper for me to print. All right, so what we are thinking about is I have a flask, and it's a round bottom flask, and it's up to a certain measuring. So we have one that goes to 100 and one that goes to 250. Let's say, for example, I'm using my 100 ml. And then we're also thinking about the pipette that we are using to add my undiluted stock. Which in this case is the acid. Now I'm writing this in blue because what I find with this assessment is that in able to kind of get the baseline understanding, it's very merit level work. And then basically if you make a mistake, that's what drops you down to an achieved. So what I do is I take the undiluted stock. We have a pipette. Let's say I have a 10 ml pipette. I add that in to my flask, and then the next thing I'm going to do is I'm going to fill it up with water to 100 mils. And that's how I make my dilution. So we are thinking about our dilution factor. So if I take a 10 ml pipette into a 100 ml flask, that's a 1 in 10 dilution, so that's a 10-fold. So I'm just creating a list of all my possible options. My next combination is, let's say I take a 10 ml and I put it into a 250 milliliter flask. I will be diluting my stock 25-fold. So 1 part acid, 24 parts water. All right, other options. So we've done the 10, we've done that. I like to do little ticks just to make sure I get all the right combos. The other option is 25 into 100, which is going to be a 4-fold. So I've done my 25, I've done my 100 again, and then the other one is 25 into 250. Which would be another 1 in 10. We good so far? All right, so that list here are my list of potential dilutions that I can have for the acid. So these are going to be my desired dilutions. Dilutions of the acid. And if you guys remember, we're going to have an equation, and these values here are acting as our desired ratios. So that's the first thing you got to work out. It's what are your choices? You good? Keep going. All right. So the next thing then is I need to make some predictions on what my titration volume is. So in order to figure out what my titration volume is, so basically what is coming out of my burette. So in this first example, if I was doing my titration with the undiluted acid, I would have predicted that the titrate volume, the volume coming out of the burette, would be 320 milliliters. So what I want to do calculation-wise is figure out, okay, based off of the dilutions and how much I use of those dilutions, what would the titrate volume be? Because we want to get a good titrate volume. So in order to do that mathematically, we can figure out what the estimated titrate volume is if we take our aliquot volume. And just as a reminder, when we're talking about the aliquot volume, let me fix that. See that again. When we take the aliquot volume, we are talking about pipetting the diluted acid. And this here, we are talking about the amount of base coming out of the burette. I think there's only one R in burette. Are we okay so far? Okay. So titrate volume is going to be equal to whatever aliquot volume I use, and I multiply that by the desired ratio. So that's what we found on the last page, and we divide it by the actual ratio. So the actual ratio is what you found experimentally. Just re-explaining kind of our ideas. Yeah. We good? Keep going? All right. So going back to our kind of original data, our actual ratio, or what we found experimentally, is 1 and 32. So I'm just keeping that in mind, that this number here that I'm going to be plugging into my equations is going to be 1 and 32. We good? All right, then I set up a table. So on the top of the table, I like to put my pipette options. What were my two pipette options? 10 and 25. So 10 milliliters and 25 milliliters. These are my pipette options. Right, what were my dilution options? There were 4 there, but realistically there's only 3. 1 and 10, 1 and 4, 1 and 25. So I'll do 1 and 4, 1 and 10, 1 and 25. I like to just order them based on concentrated to least concentrated. So these are our desired ratios. And then what I calculate inside the box is the combination of the two. So if I do a 4-fold dilution and I use 10 mils of it, how much will I be creating for my titrate volume? If you want, you guys can create like a little box. So basically, this is the planning. This is you kind of like scribbling and trying to figure out how are you going to design your experiment. And we do this all the time as scientists. We're trying to figure out, okay, how do I make something so that it works? All right, be mindful that when we are using our calculator, that we need to be careful with how we put things into the calculator, so that way we don't accidentally do the incorrect order of operations. Just trying to see if you guys can see the numbers up on the screen. Can you guys see those numbers? Or do you need to make it brighter or darker? Oh yeah, that'll probably help. Okay, can you see those numbers better? I should just stand up and look. Oh yeah, let's see. Just trying to see if it's better, brighter, or darker. It doesn't seem to make a difference. All right, so long as you guys can get an idea of what's on my calculator. Okay, so what I'm gonna do in my first calculation is I'm gonna take the aliquot volume. So this is my aliquot volume here, is 10. I'm multiplying it by the desired ratio divided by the actual ratio. So I'm going to be adding some extra parentheses to make sure the order of operations occur properly. So 2 parentheses. In the first, sorry, 2 brackets. You guys see the word brackets here. The first one on the top is my desired ratio, so this is going to be 1 and 4. And then I'm going to divide that by the actual ratio, which is 1 and 32. And then close that bracket. And I hit equal, and what that tells me is that if I was to do a 4-fold dilution and use 10 mils of that 4-fold dilution, I have used less base, but I still use quite a bit of base that I would not be happy with. 80 milliliters. Now the nice thing about doing it in a calculator is I can go back and I can easily change numbers. So I can keep everything else in my equation the same. The only thing I'm changing here is the aliquot volume. So I'm increasing the aliquot volume to 25. Do you think I'm going to use more or less base now? More, because I'm using, so now it's 200 mils. So that doesn't work. We're not going to do that. All right, let's fix that again. And now let's try 10-fold and see how 10-fold behaves. So 10, actually I'll clear it out. 10 times 2 parentheses, 2 brackets, sorry, 1 and 10, so that's a 10-fold dilution, divided by 1 and 32, close brackets. Let's see what that value is going to be. So titrate volume is going to be 32 milliliters. A little bit better. It's now going to only be 1 filling of the burette. Still not ideal though. All right. Let's change that 10 to a 25. I'm going to do a slightly larger aliquot. Probably not going to solve my problem. Now I'm back up to 80, which is not what I want. All right, try it again. I'm just going to clear that. We're going to change that. We'll do 10. And instead of doing a 10-fold dilution, we'll do a 25-fold dilution. So if I did that, I would have 12.8. That's pretty good. Let's say I wanted to do a slightly larger volume of that. That would be 25, and I would go up to 32. Cool. All right. Now, the next important thing is to make some decisions on which combination are you going to use for your method. So we have a proposed procedure down here. We're explaining why, and these are our choices here. There will be instances where you're going to have multiple things that work, and so I'm just looking to see, have you selected something that works? Just FYI for the grading, if you, grab my pens. Okay. If you want excellence on this assessment, the titrate volume that you select from this table needs to be between 10 and 25. That is the most ideal range. That's what I need for an excellence level kind of procedure. If you're aiming for a merit, we are a little bit more flexible in what we're willing to take. We will take 8 to 30 roughly. If you guys chose the 32, I'd probably say I would still take it for a merit, but it'd be a low merit. And then achieved is you've taken something else. So if you've given it a go, but the numbers are really bad, that's an achieved. All right, are we good so far? Questions, concerns, comments? Keep going? Okay. So filling in that proposed procedure, when I look at this, there's only one that will get me to the excellence, and that's a 25-fold dilution and only taking 10 mils of that 25-fold diluted solution. So this is the one that I'm going to select. It helps me if you circle or you cross out the ones you're not going to use, so that way if you make a mistake down here, I can still work out what you were trying to do. Okay? So first off, the original solution that we are proposing is diluted, and it's diluted 25-fold. So that's where I'm getting that number from. And I'm going to take a blank sample of that solution. So again, we're looking at this up here. I'm taking a 10 mil. So that's where I'm getting those numbers. All right. So the required dilution. So now I'm trying to explain, how do I make a 25-fold dilution? We go back to our previous page and I go, okay, how did I make my 25-fold dilution? I took 10 mils of my stock and I put it in a 250 milliliter flask. So I'm taking 10 mils of the original solution and I am putting it into a volumetric flask of 250. So this comes back from your dilution planning. Cool. All right. In the actual titration, I will use sodium hydroxide and I will use 10 mils of the aliquot of the diluted household vinegar. Basically what that tells you is that this number and this number should be the same because you're explaining your dilution. And then you just talk about what the color change should be. The color change should be colorless to pink. And then this last bit here is talking about the average titrate volume. So that is coming from your table that you've selected. So 12.8. And that's how you fill out your procedure. So the good news is if you fill it out correctly, that is a merit. If you make a mistake somewhere, that basically drops you from an M to an achieved. So just keep that in mind. But I do look at all your planning. I try my best to try to give you the benefit of the doubt if you make a little copying error here. So do keep that in mind, show your work, so that way I can kind of get an idea of what you have elsewhere. The other thing to keep in mind is that if you are aiming for excellence, you are doing the next page. I haven't printed it off in the practice versions because it's more or less the same essay over and over again. You just swap some numbers out. But for the excellence, I'm looking for you to justify why you needed to do the dilution, what is the upper and lower limits, why are there the upper and lower limits, really talking about that percent error, and then tying it back into your selected method. So what's the percent error in your titrate volume? Talk about how many trials you can do. So if I make a stock of 250 milliliters and I only need 10 mils for the titration, I can actually do 25 samples. So I can test it 25 times to ensure that I'm correct with the concentration. So those sort of things is what I'm looking for. This is already on Google Classroom and scanned and is part of the first video example. So I won't go through that again because I want to give you guys time to practice. All right, that's what we're looking at for those calculations. So I'll let you guys have the rest of the session to do some practice. Whatever you don't finish, make sure you're doing as homework. Feel free to hand it into my box when you are done so I can give you credit for it and you can grab yourself a little prize. And that's more or less it. All right, and I'll pass back the practice that you guys have handed in so far.